The net change theorem says that if you integrate the derivative of a function from a point A to a point B, you will know the change of the function f. So let me state that in a full sentence. So suppose that f is differentiable on the interval a, b, and continuous at a and b. It's continuous because it's differentiable interval. It should be continuous all over it. So I just want to make it continuous at the endpoints. Okay? So one-sided continuous at each point. So all in all, continuous on the interval a, b. Then what it says is if you calculate the derivative of the function, you integrate the derivative of the function from a to b, what you get is the function at b minus the function at a. So this is what the net change theorem says. So if you know the rate of change of the function, then you can find what the quantity changes, how much it changes within that time interval from a to b. All you need to know is the rate. Well, we can translate that to a velocity function. So if an object is moving on a straight line, so and the position function s of t be the position at t, so we want to recall that the velocity at t is the derivative of the position function. Okay, remember that from early on in our calc in the second chapter. So the velocity function is the derivative of the function. So let's say you want to integrate from a to b of the velocity function. You're essentially differentiating the position function, the derivative of the position function, integrating the derivative of the position function. So the net change theorem tells you this is the position at b minus the position at a, which tells you that this is the displacement of the object. In other words, it's the distance traveled in that time. Not distance traveled, the displacement of the object. I'll tell you the difference in a minute. From time t equals a to time t equals b. So this is just measuring where was the object at a, and now where is it at b, and how much distance do these two positions have? How much difference do these two positions have? So it just tells the displacement. It doesn't tell how much distance was traveled. That's because the object could have gone forward and backwards in different time within the interval from a to b. So you won't count the forward-backward distance travel, but it just tells the difference of the positions. So that's why it's only the displacement. So you see it at time t equals a, you look away, and then you come back and see it at time t equals b. You don't care what it did in between, and then that's a displacement. So that's the integral of the velocity function. When we apply this theorem to the velocity function, which happens to be the derivative of the position function, it tells you the position difference. In other words, it tells you the displacement of the object. And now, how do you find the actual distance traveled? Okay, so to find distance traveled, what you do is you integrate from a to b of the absolute value of the position, the velocity function. because you want to count the backwards and the forwards and then add them up. So that's what you do for distance traveled. So this gives you distance traveled. So to recap, the net change theorem says the integral from a to b of f prime of x dx is f of b minus f of a. This is a fundamental theorem of calculus 2 result. And displacement is the integral of the velocity of t from a to b. This actually is, you would find the function when you integrate the velocity. Distance traveled is a little bit of work. This one is a little more work, from a to b of absolute value of b of t dt. To calculate this one, just in practice, we don't really calculate the absolute value and integrate from a to b. That's a little bit of work. So to compute this guy, so the practice is you set v of t to 0 and solve. So that's the first one. Let's say you get C1, C2. I'm just making C1, C2 as solutions inside of the interval a, b. Okay, so let's put them in order. We have a here. Let's say we have C1 here, C2 here, and b here. So what it means is the velocity is 0 here, the velocity is 0 here. So it's possible that the velocity was positive here and negative here, or maybe negative and positive, or maybe both positive, or maybe both negative. Same thing here. There may be a difference in velocity. So you don't want to count them together. So what you do here is, so this is the process to compute. Set that to 0, and then find the zeros, and then integrate from a to c1 of the velocity function. Okay, it can give you positive or negative depending on whether the velocity was negative here or positive, okay, in this interval. If the velocity was positive, then this would be positive, and it would be telling you that the object was moving forward. So save this, okay, and calculate from c1 to c2 of v of t dt. It could be positive, it could be negative. Save. Integrate from c2 to b of f of t dt. Save. And then put each in absolute value, okay, and add. Of step 3. Okay, so put each one in absolute value. In other words, erase out the minuses and add them up. So that gives you the distance traveled, the total distance traveled. This one is counting the forward movement, and then the backward movement is counted, and then the forward movement is counted. So all of those are added up. Okay, so just to give you a little picture here, say if A was here, C1, C2, and B was here, and then the velocity function, let's say it went from positive to negative and then back to positive, just a possibility. So that means that the object gained some distance and then lost some distance, walk back, and then made up again with a positive distance. Positive distance here, traveled, and then the positive distance. So if you do the net distance, the net integral, then that would give you just the displacement. Okay? Whereas to find the total distance traveled, you would add this distance and then add absolute value of this distance and add this distance. That way you would have known how far the object has moved, how much gas the car has taken. Okay, so that's how we in practice compute distance traveled. Set the velocity to 0 and solve it. Okay, so and find all the zeros. Throw away the ones that not in the interval from A to B. Keep the ones from A to B, and then list those zeros and A and B on a number line. Then integrate, put in absolute values, add. Okay, put in absolute values, add. That's how you in practice compute the integral of the absolute value of g of t. All right, in the next videos I will do examples.